combinations. What's the difference? In 3 words, what's the difference between permutation and combination? Ah, that's it. That's better. Okay, what's the difference between this and this? Order. Must have order. Here, order. No order. So, if order matters, permutations. Okay? 3 people leaving the room in order. Permutation. I just want a group of 3 people. Combination. Okay? 3 people finish on the podium in a 10-person race. Who's first, who's second, who's third? That's permutation. If they just finish on the podium, a group of 3 people who finished in the top 3 places, no order in particular, combination. Okay? So, determine the probability that a 5-card hand is a club flush. Well, you kind of got to know gambling a little bit. Who plays poker? What is a flush? All same suit. And in this case, what suit am I talking about? Clubs.
Are we supposed to know that?
Well, that's why I'm telling you. No. No, you're not. Okay? Some say that's common knowledge, but hey, only if you play cards, right? No, I can tell you that. If you don't know what the heck that means, I can't. What was that other stuff we were doing? And it wasn't about math, it was about, I can't remember. Something else. Anyway. Yeah, no, I can't expect you to know that. What was it, Ashton? Oh, that was an example of someone, yeah, actually in the LA room. And yeah, how do you figure out how much sand is in a cone in the desert in Egypt if you don't know what a dune is? Yeah, good question, right? So there's lots of English and math. That's why literacy is important. So what is probability? Okay, if I put, I don't know, 4 coins in my pocket, a nickel, a dime, a loonie, and a quarter. What's the probability I'm going to pull out the loonie without feeling which size it is and the shape and all that kind of stuff, right? Say they're all the same size. Say it's old Mexican money, all right? They're all like, I don't know. Okay. Got out what? The favorable outcome is I want the loonie. There's 1 loonie in there, okay? What is the total number of possibilities if I have 4 coins in my pocket? Well, there's 4. There's a 1 in 4 chance, okay? Most of us, that's kind of common sense, right? It's like multiple choice question on a test. Okay, so favorable outcomes over, you can word this a few different ways, the total outcomes, or the number of possibilities, or the sample space. Okay? That's probability. You kind of know it, but maybe not in the formula form. What is my favorable outcome here? I want 5 clubs. And if I have 5 of the same suit, that's what they call a flush. Okay? And there's a hierarchy in poker as to what it's worth. And everything in poker is based on odds. It's based on probability. What's the hardest thing to get? A royal flush. Ace, king, queen, jack, 10 of the same suit. Okay? And I don't know the probability, but it's very, very slim. Okay? You could play cards for 5 years and never get it. All right? A pair, that's pretty easy to get. 2 pair, a lot harder. 4 of a kind, that's even harder still. And then there's a full house, right? 3 of one, 2 of the other. Lots of, okay, probability in cards. What do I want? How many clubs do I have to choose from? So I'll write this out in words. There's 13 clubs, right? There's 13 of each suit. Okay, and I want 5 of them. I want to choose 5 of those 13. You know how to write that? Yeah. Total. How many cards? Okay, I got cards in my pocket. I'm going to reach in and pull a card. How many are in my pocket? How many are in the deck of cards? This is possible 5-card hands from, well, we know a proper deck, there's 52 cards, okay? So that's what we're doing. That's my favorable outcome. I want 5 of those clubs. And the possibilities, well, there's 52 cards in there. If you just choose 5 cards at random, 52, choose 5. Lots of possibilities. So that's 13, choose 5. And total is 52, choose 5. Okay, now there's a couple ways you might see the answer here, right? We can just put that in our calculator, but what's that going to do? It's going to give us a decimal, isn't it? Let's just do the top part. 13, NCR, 5, 1287. Okay, because they might give you a reduced fraction, which everyone loved yesterday. Might give you a decimal. Oh, what's that? Well, there's quite a few ways to pick 5 cards from a deck, isn't there? Like 2.5 million. 2598960. So that is the probability. Does it look pretty slim? Do those numbers have meaning? Well, if I divide them, and I think this is what your answers are going to look like in the back. Maybe they have it both ways, I can't remember. Huh, what does that say? It doesn't say holy crap. It says 4.95 to the exponent of minus 4, okay? 4.95 times 10 to the minus 4. So take that decimal and move it 4 spots to the left. That's 0.000495. Okay, and then double check. Here's where the decimal was. That means 4 spots to the left. That's a small number, right? So 1, 2, 3, 4. This is the same as this. This is the same as this. Okay? Because do you really want to try to reduce this guy? I sure don't. Okay? And I don't even know if it does. Maybe that kind of looks like a prime number, maybe. I'm not sure. I don't even want to try to find out. Okay? So do you understand how slim that is? Just to put it in something we understand, because we always want to go 1 in something. You know what 1 in 1,000 means, right? Not very likely. You know what 1% means, 1 in 100. 1 in 13.8 million, that's Lotto 649. Odds aren't very good. What is this one? So you can divide top and bottom here by 1287, and then you'll get 1 into what is 2598960 divided by 1287. 1 in about 2,000. Okay? Not very likely you're going to get a club flush or a flush of any suit, are you? 1 in 2,000? Surprising how often it happens. Okay? Alternatively, if I take there's a 1 over button on this, I also get the number that way, okay? So, you know, some people that makes sense. So that's how likely it is. This is a pretty small number, right? Okay, pretty slim pickings. All right, so you may see a question that looks like that. Ten people are in Starbucks. including you and your 2 friends. So how many people are in Starbucks you're not friends with? An employee announces that 3 people in the store at random will win a free Frappuccino. And you're hoping, what? Yeah. And in grade 8, I would say, what's the probability that you would win that free drink? 1 in 10. Piece of cake, right? Unfortunately, you guys are in grade 12. What is the probability that it is you and your 2 friends? No, it wouldn't actually be 3 in 10, wouldn't it? Not 1 drink, there's 3 drinks there. So you got a 3 in 10 chance if it was just you. Sorry. Okay, so there's a 3 in 10 chance it's any one person in there, but it's going to be a little less probable that you and your 2 friends are chosen. All 3 of you, people might think it's fixed, right? It's rigged. Like, what's the likelihood that's going to happen? Pretty small. Let's find out. So, before we looked at clubs, what portion of the total deck was clubs? 13. Well, what portion of the total people here are you and your friends? 3. And I want to choose, well, you would like it to be chosen, all 3 of you. So you got 3 people, you and your friends, and you're wondering if all 3 of you are going to win. 3 choose 3. Okay, that would be a favorable outcome, according to the wording of this question, right? You and your friends all win, all 3 of you. What are the total possibilities here? Well, there's 10 people, and they're still going to choose 3 winners. Kind of make sense? Okay, if not, well, you know, follow it, because you're going to see an example just like it. Okay, what is 3 choose 3?
1.
Good. 1. What does 10 choose 3? Something a little bigger. 120. 1 in 120. It's less than 1%, right? Not very probable. So if all 3 of you and your friends win, you might be thinking, yeah, maybe the employee is another one of our friends. And they just ain't telling us, right? I would be suspicious. And as a decimal, 1 divided by that, okay, that's what it looks like, all right? 1%, but as a decimal, you move it 2 spots over, right? 0.01. Okay. All right. Four dogs and 5 cats are at SPCA. Every day, 3 of them get a bath. You're hoping it's not the cats. At random, I'm not going to write it, okay? What is the probability that more cats than dogs get a bath? So hopefully we understand what that means. More cats than dogs. How many are getting baths? 3. So if I got more cats than dogs, well, there's more than one possibility here, right? Remember those questions that said at least? Okay, I could have worded it like that. So more cats than dogs, well, what are my possibilities? Could I have 3 cats getting a bath? Ellie? Sure, that's more cats than dogs, right? Could I have 2 cats getting a bath? And 1 dog? It's more cats than dogs, right? Okay, could I have 1 cat, 2 dogs? No. Is there anything else? Either I got 3 cats or I got 2 cats, right? So, of the 5 cats, I'm going to choose 3 of them. And how many dogs am I going to have? Out of the 4 dogs, I'm going to have none. Because I'm just bathing 3 animals. What is 4C0? While we're kind of thinking of it. Yeah, it's just 1. I'm just going to times that by 1, which means I don't even have to do it, do I? Okay? But I need to add to that another possibility here. I could have, of the 5 cats, I'm going to choose 2 of them. And of the 4 dogs, then, I'm going to need 1 of them. Because I'm bathing 3 animals. Okay? So we've done this before, right? And there's no other possibilities, right? Okay, so those are my favorable outcomes. I got to add them together. What is the total possible? How many animals do I have? I got 9. And every day I'm going to choose 3 of them for a bath. Does anybody do this with their animals? Give them baths? Who is dogs and cats? Anybody? Okay. Do they know the word bath? They really? The dogs do. They usually know that like just as quick as their own name. Yeah. Do you give cats? I'm not a cat person. You don't give them baths? Okay. You give them the old dry bath? Okay, so you can do that in 1 step if you like, but again, you're just going to get a decimal, aren't you? So 5C3 is 10 times 1, it's still 10. Okay? So maybe I'll write that with brackets. Plus 5C2 will give you 10. Right, so I didn't write it. And 4C1 is 4. I got 4 items and I'm going to choose 1 of them. There's 4 ways to do that, right? Okay, over 9C3 is 84 possibilities if I had no restrictions. So 10 and 40 is 50 over 84. Okay, that's the probability as a decimal. Then, if you just put that in, okay, if we didn't need this as a fraction and I didn't simplify it, 0.595. So better than 50%, right? Can probability ever exceed 1? What's another way to write 1? 100%? Because that, it can't, right? I'm telling you that because you'll see it in the next question. All right, so there's another type of a problem. Let's look at some coins. Coins. My hand doesn't like to write the word probability. I don't know what it is. I always want to miss an I or a T. Okay. Yeah, but sometimes I think my thermostat's on the outside and the sun hits it and thinks it's like warmer than it is and it comes on. Yeah, I agree. It's kind of a waste of energy, isn't it? Because the temperature's perfect and then the air conditioner comes on. All right, determine the probability that at least one head is shown when you toss 3 coins. So every coin has a head and a tail, even if, you know, there's no beaver on there with a tail, right? Head's usually a picture of some person, queen. So the other side's tails, irregardless if it's got a tail or not, right? Right? Lewis? Okay, so, at least one head. Got to have a head. Can I have 2 heads? Sure. Could I have 3 heads? Sure. Okay? So what's favorable here? Or where do you want to start? What's the total number of options when you throw 3 coins? Well, let's start with 1 coin. Either you get a head or a tail. That's your 2 choices, right? If I go into a restaurant and I want a sandwich and they got 2 types of bread, I can get ham with white or I can get ham with brown. You got 2 choices. What happens if I order 2 sandwiches? How many choices could I have? Well, 2 for each one, but there's 4 choices. Because the first one could be brown, the second one could be brown, the first one could be brown, the second one could be white. The first one could be white, second one brown, right? Because they're unique sandwiches. Because one's mine and one's yours. So you can't just say white, white, brown, brown, and white, brown, because there's also brown, white. 2 times 2, 4 choices. What if I got 3 sandwiches? 2 times 2 times 2. Same thing with a coin, right? Okay, so I can get heads and tails. How do I want to write this? So possible outcomes, 2 times 2 times 2. There's 8 possible outcomes on how you can flip those coins. Because each coin is unique. Now, at least one head. This I think it's worthwhile writing out. Favorable outcomes, at least one head. Well, I could have a head for my 3 coins, for first, second, third, right? Maybe I get 2 heads and a tail. That's at least a head. Okay, could I get head, tail, head, and still have 2 heads? That's at least a head. That's fine, right? Or maybe I get a head, tail, tail. So that's 4 possibilities, 4 favorable outcomes where I got at least a head. Maybe my first one, I got a tail. Then I got another tail. But then I finally got a head. That's fine. Maybe I got a tail, head, head. And maybe I got a tail, a head, and then a tail. Still got at least one head. What's the one possibility I don't have here? Correct. Is that 7 of them? There's only 8 possible total, so You know, it can't be 8 here, otherwise there's no possible way I could get ahead. Yeah, the only one missing is the tail, tail, tail. Otherwise, I'm going to get ahead, irregardless of how I throw these coins. So, what's the probability of getting a favorable outcome here? 7 favorable outcomes, 8 total. Okay, 7/8. Whatever that is a decimal, that's fine too. So, does someone think of another way I could do this question that might be a little easier? Probability, yeah. So this always has to add up to 1. Okay, so instead of saying at least 1 head, what's the complement of at least 1 head? I'm going to throw my coins and get no head. Okay? What's the odds of getting no heads? There's only one possibility for getting that. Okay, so there's a 1 in 8 chance I'm not going to get a head. So because probability is always got to add up to 100% for the total possible outcomes, what's 1 minus 1/8? 7/8. Okay, that might make more sense to some people. Maybe it won't. But if you like it, go with it. Okay, otherwise you got to kind of do it this way. Okay? Got hit another page. All right. Did you guys have that in kindergarten? Nap time? You didn't have nap time? Right after your juice, get some sugar in you, and then 15 minutes, you guys crack.